Released in 1987 by Acorn computers, the Archimedes A440 was one of the earliest commercially available RISC-based computers. This example has a full complement of interfaces, a heavily yellowed Acorn branded keyboard, and the original 3-buttoned mouse. So let's open it up, give it a deep clean, fix the yellowing, review and mod this amazing 32-bit computer. Opening up the A440 to remove the lid will hopefully help us identify all of the rear interface ports, starting with this mystery 37-pin interface, which, looking at the internal Podule card, appears to be for a laser printer. Again, this mystery 34-pin interface appears to be a floppy disk drive IDE extension. We have a digital input-output port, a 1 MHz bus external expansion, an analog to digital interface, MIDI out and in ports, audio with 32 ohm resistance for headphones, high resolution synchronous mono video outputs, a 9-pin analog RGB video output, the serial port, a parallel printer port, and a proprietary Acorn network interface. To power this A440, we have a 240 volt power in, pass-through, and on-off switch. So, unscrewing random screws from the rear interfaces, let's take a closer look. Computer Concepts created the Laser Direct interface card, which provided the Archimedes with a powerful print controller. And this is a floppy drive IDE pass-through interface. Next up is the AKA10, which provided some compatibility from their previous BBC computer range, such as the user port, 1 MHz bus, and the analog interface. In addition, Acorn offered the AKA15 MIDI add-on interface, which we can see here. Before we can pull out and review the system board, we need to remove connected ribbons and the Podule backplane. So let's jump into our first montage. Reviewing the system board, we can see the video and sound controller, this ROM carrier daughter board, which was used to upgrade the operating system to RISC OS 3, using these 4 ROMs, which hold the kernel, filing system modules, toolbox library, and the Windows icons, menu, and pointer environment. The RISC CPU runs at 8 MHz, which is a reduced instruction set computer processor with small fixed length instructions, which was so successful became advanced RISC machines and now powers the vast majority of computing devices today. 16 1 MB 1-bit RAMs, which totals 2 MB, a battery backed up 240 byte non-volatile RAM and real-time clock, a hard drive controller, a floppy disk controller, and another bank of 16 1 MB 1-bit RAMs, which totals 4 MB, which is arranged as logically mapped RAM via the address translator, standard RAM, peripherals not managed by the input-output controller, peripherals that are video memory requests for on-screen data, fast direct memory addressing, and the memory controller, which we saw here. The underside is clean with a few additional resistors and bodge wires. So let's remove the remaining components, test the power supply, and clean up the floppy and hard disk drives. The front panel is removed via these remaining screws. And a further 2 screws, and this internal speaker allows us to detach the fascia from its housing. Taking out those metal backplate supports allows us to remove the rear panel via these 3 screws. And as the panels have seen better days, let's clean up the fascia and give them some sunlight. Because the front and rear panel plastics are brittle, let's smooth out what we can, clean them up and give them a new coat of matching paint. As the remaining parts are riveted to the base, let's clean up best we can, including the outer case. And also treat the keyboard and mouse to some lovely sunshine. Whilst we're waiting for our panels to dry and keyboard and mouse to soak up that lovely anti-yellowing sunshine, let's jump into our reassembly montage. After a few days in the sunshine, let's add some rubber feet to the base of this keyboard. Design and print a replacement function key label strip, coat it with clear lacquer and adhere it to the keyboard using these removable glue dots. Connect the mouse to the keyboard to the Archimedes, and power it on for the first time. It's not working, and that's because the CMOS RAM containing the boot up settings hasn't been connected to a charge for a very long time. Pressing the delete key resets this. It's working, but as it's difficult to capture good quality video from a CRT, let's find another way. Now we have a better screen for filming, let's load our first game, Saloon Cars Deluxe. Installing our game to the local hard disk isn't working due to a bad drive. So let's reformat it by loading the HForm basic program and running the hard disk formatter, selecting default drive 4, and as this is a 20 megabyte drive, let's select option 1. It's not working. One for another day. So let's progress with this SD card floppy drive emulator mod so we can load games from the internet.